Hello everyone. So this video is about the solutions of Chemistry Paper 1 of the recent January 2021 session. So let's begin. The first question, you have to fill in the blanks. So sublimation, in sublimation the initial state is solid and it ends up as a gas. There is no liquid state. Condensation is the process of a gas turning into a liquid, and evaporation is the process of a liquid turning into a gas. So particles in a solid are closely packed. They have given some information. Describe the arrangement and movement of the particles in a gas. So we know that in a gas the particles are very far away from one another. So there is almost negligible amount of molecular forces between them. So if particles are close together, there are forces between them. But if they are very far away, the forces between them is almost negligible. So because the forces between the gas particles are negligible, this results in them moving rapidly fast to and fro from one place to another. That is in here we have talked about the arrangement of the particles as well as their movement. That should give you the 3 marks. Then using this table you have to fill up a few blanks, not blanks, more like you have to tick the right option. Which substance is a gas at 100 degrees Celsius? So you have to basically, from this chart, you have to find that one which boils before 100 degrees Celsius. Okay, so if you look carefully, only W is the one which has a boiling point less than 100, so it should be W. Which substance is a liquid for the largest range of temperature? So largest range of temperature means after it became a liquid until it became a gas. So the range between that time when it became a liquid and until it becomes a gas, that range, that's the range they are speaking of. So if you look carefully, X, it melts, I mean it becomes a liquid at 660, but it becomes a gas at 2500. So there is a huge difference between them. The other large one was Y, but if you find the difference between 180 and 1330 and the difference between 660 and 2500, you will find that the difference for X was more than Y. So the range for X is more and the range for Y is lesser. So X should be the right answer. Which substance is a liquid at 1000 degrees Celsius and a gas at 2000 degrees Celsius? So you have to find a liquid which has melting point less than 1000 and it has a boiling point less than 2000 as well, right? So that is Y, because Y, it melts at 180 and it boils at 1330. So it melts before 1000 degrees Celsius and it also boils before 2000 degrees Celsius. Then substance Y doesn't conduct electricity when solid but does conduct electricity when molten. So this is the property which is specific to ionic compounds. So ionic compounds, they do not conduct electricity in the solid state, but they do conduct electricity when molten or in aqueous solution. So just how the melting point of a pure substance changes when an impurity is added. So basically all substances, all pure substances, their melting point decreases whenever impurity is added. Okay, so that's the answer. Then in here you have crystals of lead nitrate on one side, crystals of potassium iodide on the other side of this water filled flask, water filled container, whatever it is. So এখন what is going to happen is you will have, they will react. Main thing is they will react, and because they will react, before they actually end up reacting, 2 things have to happen. First up, these are crystals. So because these are crystals, they have to first dissolve into the water, right? Because the water is carrying them. They are placed on 2 sides of the water flask. So they have to first get carried by the water to come in contact with each other, right? So first they have to dissolve in the water, and after they have dissolved in the water, then they have to diffuse throughout the water so they can come in contact with one another. They have to diffuse. This one has to diffuse from the right to the left. This one has to diffuse from the left to the right. So only then can they come in contact with one another. So that's what happens. Then explain why solid lead iodide takes less time to form when the reaction is repeated using water at higher temperatures. At a higher temperature, the water particles possess greater kinetic energy. So when they have greater kinetic energy, that means they will move quicker. And if they move quicker, the diffusion process becomes quicker and hence the reactants collide more. So within the same space of time, the reactants will collide more because now they are traveling faster. If they travel faster, the diffusion will be faster. If diffusion is faster, they will come in contact with one another faster, meaning the reaction will take place quicker. Then give the number of different elements in lead nitrate. As you can see, there are 3 of them. Lead is 1, nitrogen is 1, oxygen is the 3rd. Give the charge on the lead ion in this. So if you look carefully, it's +2. Then you have to balance this equation. So if you just place 2 before each of them, they will get balanced. The left hand side would get balanced with the right hand side. The number of individual atoms of all the elements on the left hand side would be equal to the number of individual atoms of the elements on the right hand side. They would be equal if you place 2 before them, right? Then number 4, you have to find the percentage of air in this, of percent of oxygen in the air in this sample. So the total amount of air at the start is basically the amount of air within the syringe as well as this flask and the connecting tube. This connecting tube and this flask along with the gas syringe, the total volume of air within all three of these, you have to add them. That's the total air at the start, which is 265 inside of the conical flask and the connecting tube, and 100 is the air inside the syringe. So you add them, you get 365, and after the reaction we have 265 here still, but now it is 25 in the gas syringe. So it's 265 plus 25, that's the total air at the end. Now what's the percentage of oxygen? To find the percentage of oxygen, you have to find the difference between them, how much has been used up. So 365 minus 290, that's the amount that's been used up, and the original amount was 365. This was the original amount of air, so we get 20.5%. so this matches with our understanding of air. I mean, in air 21%, approximately 21% is oxygen, so this matches with our expected value, so it's correct. Explain how painting prevents the iron in car bodies from rusting. So painting is one of the ways of preventing rusting. So the paint, it prevents the outer air from coming in contact with the iron underneath. As a result, iron 3 oxide cannot be formed and no rust is formed. Then zinc also prevents rusting. So even if the paint is scratched, zinc still protects the iron from getting any rust. So zinc, how does it do so? Zinc is more reactive than iron. This means that the air will react with zinc first before it reacts with the iron. This will form a layer of zinc oxide on top of the zinc, making it even more difficult for the air to come in contact with the iron. So previously you had zinc and underneath zinc you had iron, but now there will be a layer of zinc oxide on top of the zinc as well. So that will make it more difficult for the air to reach the iron. So the iron remains intact. Then you have to give the name of the separation processes. If you want to separate insoluble solid from a liquid, filtration. If you want to get pure water from a solution, simple distillation. If you want to get liquid from a mixture of liquids with different boiling points, fractional distillation. If you want to get a soluble solid from a solution, crystallization. So this one might get a bit tricky. The others are pretty straightforward. So soluble solid from a solution. So what do we know crystals are? Crystals are formed whenever you have a soluble salt. So soluble salts are what? Soluble salts are basically salts which dissolve in water. They dissolve in water, right? So if they dissolve in water, they are soluble in water, but I need the soluble solid. I don't need the soluble solution. So if I want to get the soluble solid from the solution, what do? I carry out crystallization, and that will give me the crystals which are actually soluble in water. If you dissolve them, they will become soluble in water, but I need the soluble solid only. So that is why from the soluble solution I perform crystallization and I get the crystals only, which will be the soluble solid. The soluble solid is actually the crystal. Okay. Then this is paper chromatography, which dyes are present in the purple ink. So it should be dyes A and B, because if you look carefully, dye A and the purple inks, this fraction, they have the same length covered, and dye B and purple inks, this fraction, they have traveled the same distance as well. So only these two are present in the purple ink, because these have the lengths exactly equal. Explain which dye is least soluble in the solvent. So the one which has traveled the least is the least solvent. So of course D is the one, because it has traveled the least. Heavier it is, more difficult it is to move, and lighter it is, easier it is to move. So because it is heavy, that means it doesn't so easily dissolve, or it's not that soluble. It doesn't move so much. Okay. Then this is the RF value calculation. So RF value, the formula is, the RF value is equal to the distance moved by the food dye divided by distance moved by the solvent. So the distance moved by the solvent is given 120, and the RF value is 0.72, and you have to find it from here. It is 86.4 millimeters. Then this one, you have to answer whether it forms a precipitate or not. So barium chloride with magnesium sulfate will form barium sulfate plus magnesium chloride. So barium sulfate is insoluble, so it's precipitate. Then ammonium carbonate with potassium chloride. So any ammonium solution, any ammonium salt or any potassium salt is always going to be soluble. So ammonium and potassium, they will never form insoluble salts. So it's no precipitate. Then in this one, calcium chloride with ammonium carbonate, it's going to form calcium carbonate and ammonium chloride. Calcium carbonate is insoluble. Then here they have given you 4 samples and you have to differentiate between them. You have to differentiate which one is what. So if you look carefully, you have potassium salts and sodium salts, and we know potassium and sodium, they can be tested using flame test. So using the flame test, you differentiate whether the salt contains potassium or sodium. So if it contains potassium, the flame test will give you a lilac flame, and if it contains sodium, it's going to give you a golden yellow flame. So that differentiates between the potassium and sodium. The next part is you have to differentiate between the anions. So it's whether it's chloride, iodide, or whether it's carbonate. So chloride and iodide, these are halide ions. So if you perform the halide ion test, which is basically adding silver nitrates acidified with dilute nitric acid to the solution, if you perform this test, if chloride is present, you are going to get a white precipitate, and if iodide is present, you're going to get a yellow precipitate. So this is how you can differentiate between chloride and iodide. The only thing that's left is the carbonate, and the carbonate is a non-halide test. You have to basically test the carbonate using acid. If you add acid, any acid reacting with any carbonate will always give you carbon dioxide gas. So if you wish to identify the carbonate, you add acid to it, and if you get a gas which turns lime water milky, that means carbonate is present. So the gas which turns lime water milky is actually carbon dioxide, which you can only get if you have a carbonate reacting with an acid. Number 7, lithium oxide. So this is an ionic bonding question. Describe the changes in electronic configuration when lithium and oxygen react to form lithium oxide. So the lithium atom loses its single outer electron to the oxygen, but we know oxygen needs 2 more electrons. So if the lithium gives one of its the outer electron to it, it still needs 1 more to have a full outer shell. The oxygen needs still 1 more electron. So it's going to get the remaining electron from another lithium atom. So 2 of the lithium atoms, they give the outer electrons. So previously they were 2, 1. They become, after the electron has been transferred to the oxygen, they become simply 2. And the oxygen previously it was 2, 6. Now it becomes 2, 8 by taking 2 electrons from 2 separate lithium atoms. Then this is to find the heat energy change. So the initial temperature is given 17.3, and after adding we get 27.7. If you look carefully, this is giving you 27.7. So 27.7 is the final. This is given, rises, subtract them, 27.7 minus 17.3. So then we use the heat energy change. The formula is Q is equal to mc delta theta, where m is the mass, c is the specific heat capacity, and delta is the change of temperature. So mass of the solution is here. It's given 400 grams. The mass is given in the first part of the question. So 100 is the mass, C is given 4.2, and the change of temperature we found from here 10.4. Then we are finding the molar enthalpy change. Molar enthalpy change, the formula is energy change by number of moles. So energy change is given here 5210, and the number of moles also given. So we divide them, and we know that because it is an exothermic reaction, it's going to be a negative sign. Exothermic means negative sign. Give a reason why scientist does the experiment in a polystyrene cup. Polystyrene is an insulator. That means the heat loss to the outside would be prevented. The heat loss to the outside would be prevented. That would give us a more accurate value. Then number 8, you have to describe the states and the color of acetylene. Acetylene is the last element in group 7. So it's going to be a solid, of course, because we know as we go down the group in group 7, the melting boiling point increase. And also the color becomes darker, so it's going to be black. Now we use the formula to find relative atomic mass to find this one. Percentage abundance multiplied by mass of the isotope plus percentage abundance multiplied by mass of the other isotope. You get this one. They give a reason why both isotopes of bromine have the same chemical properties. Chemical properties depend on one thing only, that is the proton number. And as we know that isotopes are atoms of the same element with the same proton number. That's why their properties, chemical properties, would be the same. This is about differentiating about which one comes first in reactivity. So if we look carefully, chlorine is able to displace both bromine and iodine. That means chlorine is the strongest. Then if you look at bromine, bromine is not able to displace chlorine, but it is able to displace iodine. That means bromine is the second strongest, which means iodine is the weakest. If you look carefully, iodine doesn't react with anything. Why? Because it's the weakest among the 3 and it cannot displace anything. And suggests why the student doesn't need to add bromine solution to sodium bromide. So there will be no reaction if the anion of the solution is the same element as the other solution. So you have bromine solution which contains bromine, and you have sodium bromide which contains bromine as well. So you have two things which contain bromine, they will never react. So whenever you have a situation, whenever both the substances contain the same element, they will never react. Then this is for a redox reaction. So redox reaction, we know that if the oxidation number increases, it's oxidation. If the oxidation number is decreased, is reduction. So if you look carefully, bromine had oxidation number of 0, it became -1, so it's reduced. Iodine had oxidation number of -1, it became 0, so it is oxidized. Then what is a hydrocarbon? Why is propane a hydrocarbon? Because it contains carbon and hydrogen only. Poisonous gas which forms in a limited supply of air when propane is burnt, it's carbon monoxide. Why is it poisonous? Because it reduces the flow of oxygen in the hemoglobin of our blood. Describe the forces of attraction between the atoms. So it's a basic covalent attraction. So in a covalent attraction, what happens is the protons of the individual atoms, they are attracted to the outer electrons of the atom to which they are bonded. So the individual protons, they are attracted to the outer electrons of the atom with which they are bonded. So that's why there are relatively strong attractive forces between the protons of each carbon atom with the outer shell electrons of another carbon atom or another hydrogen atom. So that's what happens. Okay. Now propane can be produced by cracking. Why is cracking essential in the industry? So smaller hydrocarbons are more in demand than larger hydrocarbons, always. Okay, they're always more in demand than larger hydrocarbons. Moreover, smaller hydrocarbons may be used as fuel while larger ones cannot be used. So you can never use, carbon number which is more than 10 for fuels. Carbon number less than 10 is what's, you can, if you go up to carbon number 15 or 20, you cannot use them as fuels, but you can use, up to carbon number up to 10, you can use mostly as, fuel, because you can have diesel oil, you can have petrol oil. Those fall within carbon 1 to 10. Okay, so those are the ones which are essential for fuel in running cars or in use of, use in our houses for cooking. And the other one is, in addition to these, the alkenes obtained from cracking may be used in the process of polymerization. So alkenes are something which we get from, cracking. If you look carefully in here, we are getting C3H6 and C2H4. Both of these are alkenes. So alkenes are used in polymerization process to get polymers. Okay, so that's why alkenes you get from the cracking process is also very useful. Then you have to write what's coming from here. So this is a substitution reaction which takes place in the presence of ultraviolet radiation from the sun. So one of the hydrogen atoms is replaced by bromine. We get C3H7Br, and the bromine which is left from, after the reaction, that bonds with another bromine to form Br2. Okay. Then number 10, you have to draw the curve of best fit, and then they are asking you to use the graph to find the boiling point of the alkene with 7 carbon atoms in its molecules. So 7 carbon atoms, if you look carefully, it gives us a boiling point of 101. So it should be 101. Explain the trend shown by the graph. Greater the number of carbon atoms, if you look carefully, greater the number of carbon atoms, greater is the boiling point. So why does this happen? There will be a greater number of protons and electrons. So if you have more atoms, there will be more number of protons and electrons, which will result in greater attraction. This means that a lot of heat would be needed to break the bonds and to boil them. Okay, so greater the attraction, more heat would be required to break the bonds and boil the substances. So in here you are provided with 2 isomers of C5H12, which is pentane. And why are they isomers? Because isomers means same molecular formula but different display and structural formula. That's what we are seeing here. Same molecular formula, both C5H12, 5 carbons, 12 hydrogens, but not the same structural or displayed formula. One is straight chain, one is branched chain. This is how you find empirical formula. So you apply the steps, you will get the empirical formula, which comes to C2H5 shown. Now this is an alkane. They have told us that this is an alkane. So which alkane has this specific empirical formula? So we know alkanes, they have this general molecular formula CnH2n+2, So we apply this and see which one matches with this one, and the only one which matches is C4H10, because C2H5, for it to become C4H10, what do? We multiply C2H5 with 2. If we multiply C2H5 with 2, we are going to get C4H10. So this is the only one which matches the criteria. Then in here, you have to find the values of X, Y, and Z, the coefficients. So they have given some information. They said that 308 grams of carbon dioxide are produced. So 308 grams of carbon dioxide, if you want to find the number of moles, you do mass by molar mass. It comes to 7. Then for water, do the same, mass by molar mass, you get 8. So X is 7, Y is 8. So after we have gotten X and Y, we can now calculate how much oxygen there is. So on the right hand side, if you look at carbon dioxide, it has X CO2. That means 2 oxygen atoms multiplied with X. So X is 7 multiplied by 2, that gives us 14. And here you have 1 oxygen atom multiplied with Y. So Y is 8, 8 into 1 is 8. So in carbon dioxide, you have 14 oxygens in here, and in water, you have 8 oxygen atoms in here. So we add them, we get 22 atoms. So we have 22 atoms of oxygen, and we know 22 atoms means 11 molecules, because oxygen always exists as a molecule, diatomic molecule. So 22 atoms means 11 molecules of oxygen, so Z should be 11. Then number 11, this is, I believe, the last question. Yes. So give the test for oxygen, it relights the glowing splint. Describe a method to show the solid manganese oxide is a catalyst in this reaction. So what do we know? Catalysts are substances which remain chemically unchanged at the end of the reaction. That means their mass doesn't change. The mass at the beginning will be the mass at the end. So we have to basically measure the mass at the start, which we have already measured. It's 1 gram. And then after the reaction is over, we have to measure the mass again. So because it's a solid manganese 4 oxide, we can filter it out. It doesn't dissolve, right? We can filter it out. So what's going to happen is, first we carry out the reaction, and then after the reaction is over, we filtered the mixture. Once we filter the mixture, this solid manganese 4 oxide will be collected as a residue, and then we have to dry it because it was inside the water. So we have to dry it. So once we have dried the manganese oxide, and then we measured the mass of the manganese 4 oxide which is dried, we will see that it comes to 1 gram, which matches with the initial value, meaning it's a catalyst. It didn't get used up in the reaction. Then in here, they are telling us find the rate of reaction. So how do we find the rate of reaction? By finding the gradient of the graph. How much reaction happens per second. So we find the gradient of the graph. So they told us to find the rate of reaction up to the first 120 seconds. So if we zoom in, 120 seconds, at 120 seconds, the volume is this much, which is 270. So 280. It's 280. 260, 270, 280, 280. So 280 is the volume of the hydrogen which has been formed in 120 seconds. So we find the gradient. That gives us rate of reaction 2.33 centimeter cubes per second. Then use this equation and the particle theory to explain why the rate of reaction is greatest at the start of the reaction. So at the start of the reaction, what happens at the start of the reaction between zinc and hydrochloric acid? Zinc is, it's large in amount because that's the start of the reaction. You have it in plenty amounts. So at the start, it's a lot, but as the reaction goes on, it gets used up. This means that there are lesser zinc atoms within the same space. Previously, within the same space, there were more zinc atoms because it was the start of the reaction. As the reaction progresses, you have lesser zinc atoms available within the same space, meaning there will be lesser collisions between the zinc and hydrochloric acid. Usually the HCl, usually the acid is added in excess. Usually the acid is added in excess. The solid is the one which is lacking. It's the limiting reagent, the one which is lesser in amount. So this means because the zinc gets used up, there will be lesser collisions between zinc and HCl, and as a result, the probability of successful collision decreases. If the probability of successful collision decreases, there will be lesser amount of zinc chloride produced per second. Then on the grid, draw the curve you would expect to see in this experiment. In this experiment, what happens? You use a higher temperature, but keep everything else the same. So if you use the highest, if you use a higher temperature, what happens? The rate of reaction increases. That means the gradient increases. So this new graph, which is of a higher temperature, it would have a higher gradient. So it would end at the same point. I mean, it will end at the same volume of hydrogen. That doesn't change because that never changes. The only thing that changes with higher temperature is the rate of reaction. So that is what changed. The gradient increased. Then explain why the rate of reaction is greater if the same mass of zinc powder is used instead of zinc lumps. So if you use zinc powder, it's granulated. Granulated means it's spread out. The area is spread out. Powder means the area is like this. It's spread out all over the place. And lump means it's just one lump. So of course the granulated powder has more surface area. So if it has a greater surface area, there will be more collisions between the reactants, meaning the probability of successful collision increases, and as a result more reactions happen per second. Then the last question is about finding which one is in excess. They are telling us we have to show that HCl is in excess. So first we find how many moles of zinc there are. So zinc, they are telling 0.55 grams is the given mass, molar mass is 65, so we get this many moles of zinc. Now if we have this many moles of zinc, according to the mole ratio, if 1 mole of zinc is there, it will react with 2 moles of HCl. So whatever the moles of Zn we found, we have to multiply with 2 to get the required mole of HCl. So we got this to be the required mole, 1.692 10 to the power minus 2. But this is the amount we need, but we are provided with 2.5 into 10 to the power minus 2, which is more than what we need. So this is proven to be in excess. So that's the end of the paper. Thanks for watching.